In this section, we are looking at process in more detail. The content of the process section is the following. We are going to discuss why process is important in business and what some of the process-related problems are. We provide the key concepts and systemic guiding principles of process, and also how to manage and design process. Why is process important in business? Global markets are increasingly efficient. To be competitive, organizations need to manage process. They need to manage efficient process flow in all their activities, especially in their business processes. They need to continuously improve the processing and the output. They need to develop their integration into the supply chain, in other words, upstream and downstream development, making alliances within the supply chain to increase efficiencies along the whole supply chain. They need to manage the byproducts of their processes that is sometimes overlooked, that byproducts like pollutants, for example, become increasingly important. The impact on the planetary systems will become increasingly important and laid at the door of business. Some of the typical process-related problems in an activity system or function are that there is inadequate quantity and quality of input and output MBI. This could be defective supply and outputs, or over and under supply of outputs and inputs. Then another problem is inappropriate MBI flow. It could be too fast, too slow, too long, too short distances and so on, causing delays, blockages in processing, deliveries, or over-under supply, or mistakes, faults, waste, amongst others. And then there could be wrong processing, the wrong choice of processing methodology, or faults in processing, mistakes, duplications, poor quality of output, and the like. Other problems are discontinuities in processing, over, under, discontinued production, blockages, waste, and so on, and inadequate processing and disposal of MEI byproducts. In other words, pollutions, accumulation of toxins, health or safety hazards, amongst others. The process-related problems within an entity system, first of all, disorganized MEI flow within any of the activity systems of the entity system, which is part of what needs to be considered in any kind of activity system or function redesign. Then a process issue is the discontinuous MEI flow between the activity systems of an entity. In other words, the output of one activity system is not tapped by another activity system because the outputs do not meet the requirements, or availability is not known, or there are byproducts like pollutants, chaos, confusion, or free radicals in physical systems, which are ignored or not processed and clog up systems within the entity system. And there could be insufficient or faulty MEI flow between the output of an activity system, in that it is not what the other activity system needs, or that MEI is in short supply, between different parts of the activity system. So activity systems of the entity compete for the same resources. That happens very often, that the same labor would be required in different functions of an organization, or that budgets are allocated differently between different activity systems of the entity system. And another problem could be that delivery of required MEI is not in time, it's too late or too early or doesn't happen at all.
This section deals with key concepts and systemic guiding principles of process. Let us look at the definition of process. A process is defined as a flow of substance in space and time. For example, if we observe a substance like water flowing in a riverbed, refer to this as process. Or if we observe a substance like different parts being assembled into a car, for example, then we would call this a production process. Substance is one of the 7 forces of system organization that we will discuss later. We have defined substance as consisting of matter, material things, energy and information. We also say that these matter, energy, information always occur together and form a field of matter, energy, information, and that these MEI fields are what substance is about. The graphic depiction of substance is an MEI dot, a gray shape like that, which consists of matter, energy, information interacting. So as soon as we have a flow of these MEI dots, we have process. Substance flows, and the flow is represented by the orange line, and the flow is what we refer to as process. We need to distinguish between process and process system. If we are talking about a flow of MEI that we can observe, we talk a process. If this process is without a purpose, it is a random process, like a book falling off the table or an accident would be a random process. However, if the process is purposeful, we denote that by the aims error that we have discussed in the previous section. And if this flow of MEI is structured and governed, then we have a process system or activity system. In other words, our flow of dots is organized, and that is called an activity system and is depicted by an arrow. The arrow depicts organized process. When we hear the word process in management, like for example business process, then we typically refer to a process system or activity system, not a random process. One would use the word random to denote those. What are some of the systemic guiding principles of process? The first guiding principle is that during processing, the MEI input gets transformed into an MEI output. So for example, if we are having a process system like cake baking, the ingredients like butter, sugar, milk, eggs, etc. get transformed into the MEI output, which is our cake. So the graphic depiction of the process is we have the MEI dots as an input on the left, and we have the processing taking place in our system from one step to another. So in the cake, it would be we are assembling the ingredients, we are mixing them, we are pouring them into a cake tin, put them in the oven for baking, and so on. And it gives us the MEI output, which is the cake. The processing MEI, while it is being processed, the dough, the half-finished cake, etc., is also referred to as MEI throughput. The processing or acting on the input substance transforms it and adds value. If we talk an example again, as we are taking the ingredients of the cake, as we start mixing them, in other words, processing them or acting on them, they change their shape, they become smooth, foamy, and then they have value added that wasn't there before, because as we put the ingredients in, they were separated and the processing mixes it and creates new value. As we put the dough into the oven acts through heat on the dough and adds value. It transforms the substance, adds value, and we have the cake that we can eat. The output is greater or more or different than the sum of its inputs. Now, we have learned before that the essence of system theory is emergence, new quality that arise in the interaction of systems. And we have the same again in the process. We have learned the famous systems saying that the whole is greater or more or different than the sum of its parts. So in the context of a process, the output, the whole that comes out of the processing line, is more or greater or different than the sum of the ingredients that we have put into the processing. We can have, however, also process where no value is added. Now, in business, when we do business process redesign, one of the issues we are looking at is, does this process add value? If not, we tend to cut it out. So typically pushing a piece of paper from one side to another side doesn't really add value most of the time. So it is one of those processes which we find is unnecessary and we want to cut out. So business process redesign is really about identifying which processes add value and which don't, and to reduce those which don't. Each transformation that happens of meta-energy information marks a processing phase. So for example, as I assemble the ingredients, I have one phase. As I start mixing them, I have another phase, etc. And the MEI gets transformed in the process of it. This processing can occur in sequential or in parallel phases. What that means is that sequential processing occurs one after the other. I first have to unwrap the butter from the butter paper and put it in the pan before I can mix it with the egg, which before I put the egg in, I have to get it out of the eggshell, etc. So there are sequences involved, the assembly of ingredients, the mixing them, the pouring them, the baking them, the glazing them. I have to do the one after the other. This is called sequential. At the same time, we also could have parallel processing going on. For argument's sake, I could preheat the oven while I am mixing the ingredients so that the temperature is correct when I put the cake in the oven. All process redesign is not more complex than a combination of the parallel and sequential processing phases, except that sometimes there can be very many and create an apparent complexity with feedback loops, etc. In an organizational context, we call the processing phases also sub-activity systems. In other words, if the processing phases are purposeful, structured, and governed to achieve their aim, which is a sub-aim of the overarching aim, then we call them sub-activity system, and they can be parallel or sequential. During processing, the MEI fields split up and are recombined into products and byproducts. So if we go back to our cake baking example, the products at each phase would be the assembly of the ingredients, the first orange dot, the dough, the second of a particular consistency or quality would be the second dot, baking it, the third dot, the fourth dot would be the final cake. At each phase, we also have byproducts that are being produced. So once I'm assembling my ingredients, part of the ingredients go into the mixing bowl, the other part goes into the rubbish bin. The mixing bowl, once I pour it into the baking tray, then some of the dough stays behind and will be washed away with the dishwashing. While I'm baking it, some of the byproducts will be that the kitchen is heating up. So at each phase we do have products and byproducts, and there are different activity systems or process systems that deal with those byproducts. So the rubbish goes into the municipal rubbish dump where it is being sorted, composted, etc. The dough in the bowl goes into the sewage system. The heat of the kitchen is radiated into the kitchen. So there are various activity systems that deal with those, and it will be increasingly important for organizations to manage not only their products but also their byproducts, the impact on the planet. Because one of the reasons why we do have challenges such as climate change, polluted water, soil, etc., is that we have given our byproducts to the planet, and the absorption capacity of the planet to deal with those has been exceeded. So we need to actively manage those to get planetary systems back into equilibrium, because if we are overloading their absorption capacity, then whole ecological systems can go into disarray as we observe through climate change. And increasingly, it will be legally enforced from organizations in future to deal with their byproducts. Another way of looking at byproducts is how Buckminster Fuller talks about it. He said byproducts are merely resources we haven't tapped yet. So we haven't looked at those systems and made them profitable. We haven't linked businesses to those. We have done it with some, making electricity from municipal rubbish dumps, for example. There must be many more such opportunities. Processes continue in time and space. That is another important principle. It is the MEI that continues in time and space, and it continues through tapping of MEI. So if you look at that graphically, we have our process system with the different phases. So the first phase produces an output, for example, part of a machine which needs to be tapped by the next phase as input to produce maybe the finished product, a finished machine, which is being tapped by the next phase, which could be a warehouse, and so on. So the output of one phase is being tapped as input by the next phase, being transformed in processing, and then again tapped by the next phase. Tapping really means accepting or accessing the output from another system to use as an input to one's own system. Tapping can be passive or active. Now, passive tapping means allowing MEI to continue. If we are looking at the cake tin, for argument's sake, the cake tin taps the dough passively as I pour it in. It just allows it to happen. If you are watching that video and you're not really actively participating, you allow it to wash over you, then you tap passively. You have various filters that allow certain information to go in and other information is being filtered out. By comparison, if we do active tapping, then we are seeking out information. You would have done active tapping when you pressed the start of the video, you wanted to see it, you made an effort to actually tap information. If you go into a library or go into a search, then you are going to an even greater effort to seek out specific information. So tapping can have a range of modes between passive and active. Systems must have the ability to tap. This means the system must have a container in inverted commas where the previous output can flow in. For example, if the cake tin is too small, or if I try to pour a dough into a glass with a narrow rim, the glass would not have the ability to tap, to take the dough. If I'm speaking a language you do not understand, you don't have the ability to tap the information that you get. If the specifications of my output are not matching the specifications of the input, it will not continue. The next system will not be able to tap the output of the previous system. So that's very important to have quality norms that are specified according to how the flow of MEI should continue, so that the other system has actually the ability to tap. Active tapping, moreover, requires a deliberate will to tap. Before I go out to actively access something, I must have the will to do so. So in other words, in many tapping situations we need both the ability and the will. A child in education, for example, may have the ability to tap, but it may not have the motivation or the will to tap. Then tapping or learning will not take place. Or there may be the will, but not the ability. If MEI flows across systems boundaries, we speak of external supply chains. If they occur inside the organization, they're internal supply chains. Supply chains are dynamic. What we mean by that is that in a supply chain, matter, energy, information, or the products flow one direction, while the information flows back in the reverse direction. So, for example, a car manufacturer who wants to know how many cars it needs to produce, they need information about the likely future demand, and that information flows from the potential customer to the retailer, to the wholesaler, to the organization, while the actually produced cars flow from the supplier, manufacturer, to the wholesaler, to the retailer, to the final customer. And in this flow of production or products versus the information flow which goes the other way, there can be time delays. And this can make supply chains very dynamic and counterintuitive for managing. It can create a situation where when there's little demand, I have to actually increase production to accommodate the time or the demand at a later point in time. An example of a supply chain from the fruit juice industry is the first phase would be growing fruit. This is done by the farmers. The second phase would be the pulping, typically done by a different company. Third phase is mixing the juices. Fourth phase, transporting it to the market, into the shops. So while the transporting, the mixing, the bottling can be done in relatively short space of time, growing trees to get the ingredients for the pulping is taking a longer time. So if there was a close relationship in the supply chain, for example, in a particular region, between the local farmers and the local fruit juice bottling industry, and suddenly the flavors change, it takes time for the farmers to adjust and produce those new flavors. So again, there are time delays in the supply chain that may have to be considered. And the output of one system is tapped as an input by the next system, etc. If tapping doesn't take place, then there is no continuity of meta-energy information along the intended supply chain. But as we heard earlier, MEI continues. This is a systemic principle. So the outputs would then continue in a different direction. It could be that the farmers produce too much fruit that can't be tapped by the other industries, so they may have to end up on the compost heap. And it's a different system that taps it. But there will always be systems that tap MEI.
Processing, the transformation flow of MEI, has some generic guiding values. One of them is effectiveness. This means that the right value is created during processing. The right MEI transformation is taking place in terms of the overarching aim of the activity system. Another guiding value is efficiency. This refers to the MEI flow in time and space, that it does not waste energies, that it is according to the appropriate speed, not too slow, not too fast, that there's no waste of resources, etc. Then there is continuity of the MEI from one sub-activity system to another, that the output of one activity system is tapped by the next activity system, and that there are no overproduction or undersupplies along the way, or blockages or discontinuities. Sustainability is another guiding value. We have to select processing MEI and also support and acting MEI that is within limits of stakeholder systems, that does not deplete stakeholder systems or overburden stakeholder systems in terms of byproducts or negative impacts. So it must be sustainable. Another guiding value is optimization. This refers to the appropriate mix of selection of processing method, ingredients, and also acting and support MEI in relation to each other, so that the outcome, the intended aim of the system is achieved.
This section deals with managing and designing process. To design or redesign a process involves the following.
We need to ensure that we set up processing in such a way that the aim is being achieved. That first of all requires that we select the appropriate processing method overall. Then we need to determine the according processing MEI.
In other words, what is being processed, the material, energy or information that is being processed. Then determine the processing phases. As we learned, each time there's a qualitative change occurring in processing, this marks a phase. We need to determine the sequential as well as the parallel phases. And then we also consider tapping. Between the different phases, there could be tapping involved of the processing MEI. We could look at what is the activity. For example, is tapping involving storage? And then what happens to the processing MEI during that tapping phase? Is the quality of the good that is being stored affected or not?
When we redesign a process, we also need to consider the byproducts that are being created at each phase, and we need to design appropriate continuity of those byproducts. So that could imply also designing different systems that are tapping the byproducts and processing them.
Let us now look at the principles for managing process. The first one is we want to optimize the flow of meta-energy information. We want an efficient MEI flow. So when we do just-in-time tapping of spare parts, we do it because of efficiency. We also need the right quality of processing MEI. If we don't have the right ingredients or the right quality, we may have a process that is clumsy or that is not flowing easily. We also need to manage continuity of MEI flow of both products and byproducts, as we have learned. So we need to understand that our products are of a quality that can be tapped by the next system, and we need to make sure that the byproducts we produce are being tapped by appropriate systems who are designed to do so. Up and downstream development or supply chain management can help us with the continuity of MEI flow. The more we have alliances with our suppliers, for example, upstream, and with our customers downstream, the more we align the specifications of the products that are taken up by us, that are produced by us and taken up by the customer, the more smooth the flow of MEI will be. It is also important to manage tapping. Now, tapping means accessing the output, like I turn on and off the tap in the water. So if I turn it on, water pours out and I can tap it in a basin or whatever. This is what we mean by the word. All output needs to be tapped, taken up, accessed, bought, taken in, used, whatever words we want to use, by the next system. One important principle around tapping is that the responsibility shifts with tapping. This is illustrated by the famous saying that I can lead the horse to the river, but the horse must drink. So the one system leads the horse to the river, but if the horse doesn't want to drink, doesn't want to tap the water, there is a discontinuity of the supply chain. I can offer you knowledge about system thinking. I must do the best I can to make it accessible to you, understandable to you. But if you want to learn it, is your responsibility. Having said that, I also have to say that tapping can be mediated. In a face-to-face situation, when I see I have now talked so many systems concepts and the eyes of my audience are glazing over, then I realize I seem to have overloaded them with information, and I can try to mediate that the understanding is taking place. I may give more case studies, I may explain again, I may ask questions. There are various methods of how I can mediate tapping. Many marketing techniques, advertising, promotions, all those are techniques that businesses use so that their clients, customers, tap the products that they have produced. Tapping can involve power games. If I go back to the horse and the river, I can illustrate that. If the horse doesn't want to drink, and I mediate now with niceness and say, dear little horse, look at the nice water, please drink, and the horse refuses to drink, I may employ a bit more power over mediation tactics. I may take the head of the horse and push it in the water. The horse doesn't want to drink. I may ask somebody to come and with a pail of water I open the mouth of the horse and we pour the water in. The horse still doesn't need to drink. The horse is free to choke to death. So the power over in tapping can become deadly for the following system. So the power games are normally in tapping situations, in relationship situations, when one statement was intended, another one is being heard, to give another example. So there are very typical situations that arise in tapping. Tools for managing process. To carefully select the correct MEI, in other words, to pay attention to procurement, both in terms of the right quantity, right quality, but also just on time delivery. Then it is important to select the right processing method, mediating the tapping of MEI. That means ensuring that the output of one phase is smoothly flowing into the following phase. And the most fundamental tool for managing process is process redesign. This is actually the redesign of the process in interaction with the redesign of the structure of the process and also the governance of the process. So process redesign is actually activity system redesign and involves all aspects of process, structure and governance redesign.
Another tool usually used in processing is the optimization of process, that the least energy input achieves the aims. That could be least resources, least time, least cost, at particular levels of quality, etc. Those are balancing acts between the processing MEI and the acting and support MEI, as well as their configuration in time and space.
Let us now look at the application of process in an activity and entity system. Process in an activity system is concerned with the flow and transformation of matter-energy information from one sub-activity system to another along the whole supply chain. As we have learned previously, a sub-activity system is always a processing phase, whereby input MEI is processed and becomes output MEI. We have also learned that processing gives rise to products and byproducts, whereby products and byproducts move along different supply chains. In the context of sustainability, the byproducts are very often forgotten.
The process perspective in an activity system deals with the organization of process, namely the MEI flow and the MEI transformation within the activity system. While the entity system perspective of process is about the optimal MEI flow along and across all activity systems within the entity system.
The process perspective in an entity system is concerned with the flow of matter-energy information between the different activity systems of the entity. This flow is facilitated by the structure of the system. In the context of an organization, we are talking about an organogram or organizational structure.
How do we manage process within an entity system? Well, first of all, we need to identify and categorize the processing problems within the different functions or activity systems of the organization. We do that through the biometrics diagnostic survey. That survey automatically brings up all problems, including processing problems. Some of those processing problems can be solved because they are non-systemic, so they are maybe optimizing problems within an activity system or mistakes that can be corrected within an activity system. So those are non-systemic problems. And then there are processing problems that emerge from the interaction of different activity systems that create MEI problems in different activity systems. These need to be dissolved through the redesign of MEI flow within activity systems. They need to be created in an orderly fashion according to the requirements of other activity systems. This requires order in both a functional and cross-functional flow along the activity system supply chains.